Come on heartily, walk across the moon. A mission to explore the possibilities of life on Jupiter's 4 moons. The European Space Agency, ESA, has completed preparations to send a satellite to Jupiter. One of the most spectacular missions ever sent by the agency. The satellite will leave Earth's orbit on Thursday, for an 8-year probe to reach Jupiter's largest moons by July. Scientists have ample evidence that the icy worlds of these moons, Callisto, Europa and Ganymede, have oceans of liquid water deep within them. The purpose of this ESA mission is to find out whether the conditions needed to sustain life exist on the moon. Michelle Doherty. You need patience and vision to investigate the outer solar system. The project is being called Jupiter Icy Moon Explorer, or JUICE for short. JOICE is not trying to figure life out. It will not send back photos of alien fish. But it could help determine whether simple microbial organisms, animal microbes, are likely to exist in the hidden ocean conditions of Jupiter's moons. Professor Carol Mendel, Director of Science at ESA, says it's not a crazy idea. In every extreme environment on Earth, whether it's high acidity, high radiation, low temperature, high temperature, we find microbial life in one form or another. He told BBC News. If you look at the volcanic luminaries at the bottom of the Earth's oceans, they also look like alien worlds. If we have a similar situation, there is no reason why microbial life cannot exist elsewhere. And these are the conditions we want to study through JOICE. The Italian astronomer Galileo Galilei identified 4 large moons of Jupiter in 1610. During its journey, the JOICE satellite mission will not only go to the moon called Io. The $2 billion mission will be loaded on an Ariane 5 rocket and launched from Kourou in French Guiana at 9:30 a.m. British time. But it becomes one. Ariane 5 will not have enough energy to carry JOICE to Jupiter's moons within a useful time frame. Instead, it will send the spacecraft on a path around the inner solar system. A series of flybys between Venus and Earth will carry the mission to its intended destination through gravity. Flybys, a point-by-point flight, especially a close approach by a spacecraft to a planet or moon for observation. The mission is expected to enter the Jupiter system by July 2023. The mission will fly past these moons 35 times before the JOICE satellite settles into orbit around Jupiter's moon, Ganymede. A total of 10 instruments are installed in the spacecraft. There are various cameras, particle detectors, radars to map the features of the moon's subsurface. There is even a tool for meteorological assessment that is used to create three-dimensional 3D maps of the surface. But it's the UK-supplied magnetometer that can provide some of the most influential data. An instrument built by Imperial College London will tell us about the properties of the moon's hidden oceans. And especially for Ganymede to act effectively, the information must be detailed enough. Professor Michelle Doherty, principal investigator of Imperial's magnetometer, explained, "We know the depth of the ocean, its salinity, how deep the ocean crust is, and whether the ocean is in contact with the mantle. We'll take it. So we'll gain an understanding of the moon's internal structure. And with observations from other instruments looking at the surface, we'll be able to solve the problem of whether there is organic material on the surface." Carol Mandel. We think liquid water is a condition for life to exist. We have learned from life on Earth that life requires 4 essential ingredients: liquid water, some type of nutrient, an energy source, and time, a long period of stability during which organisms can gain their footing and can establish itself. If not now, then in its distant past. We have long considered Mars to be the most likely candidate to support life after Earth. But for astronomers, scientists who study the possibility of life elsewhere in the universe, the ice-covered moons of Jupiter and Saturn are really starting to pique our interest. Small, alien-looking insects can be found in deep sea volcanoes on Earth. These worlds may exist far from the Sun, in the outer ring of the solar system's cold atmosphere, and may be able to provide the 4 ingredients necessary for life, possibly even providing energy. It is not the light and heat of a star, but the ever decreasing gravity of the moons and the processes of the giant planets pushing away from them. It is this elasticity that provides the means to keep water in liquid form and can also drive the volcanic systems on the ocean floor that Professor Mandel mentions and that some scientists believe I could have been the cause of the origin of life on Earth. If I were a betting man, I'd probably put my money on Europa being alive, existing today, says Professor Louis Dartnell, an astronomer at the University of Westminster. Its chances are much higher than the current efforts to find life on Mars today. Artwork: the U.S. Space Agency's Clipper spacecraft will launch next year. The U.S. will launch its companion mission, known as Clipper, next year. It will focus on Europa, building 50 flybys, some of which will be less than 25 kilometers away. After a close pass by a planetary destination, a spacecraft usually goes into orbit later and then another mission attempts to land. That's how progress has been made in research on Mars, where we're going to take an extra step, which is to try to bring material back to Earth to study in the laboratory. Exploration of the moons of Jupiter and Saturn is not as advanced in sequence, but it is possible to envision projects later this century that would land on these fascinating outer solar system bodies and dig up their icy layers for the waters below. Get a sample. Astronomer Royal, Professor Sir Martin Rees, says, if we find evidence of life on the moons of Saturn or Jupiter, it will almost certainly be an independent and first-of-its-kind discovery. The research would then send an important message that life, if this research had started twice independently in our solar system, could not be a rare coincidence, and that life, is definitely in our galaxy. I exist in a billion places, and this discovery completely changes the way we look at the universe. Then we look to the sky to understand the secret of life. A rare green comet or comet is making a visit to our solar system after thousands of years, and it will likely be visible to the naked eye on February 1st in the northern hemisphere. The comet will pass close to Earth for the first time in 50,000 years and may stay around for a month. NASA officials say the icy comet was first spotted in March 2022 when it was close to the orbit of Jupiter. With a handheld telescope it will appear as a small glowing green object. We want to detect the presence or absence of certain molecules in it, such as water, carbon dioxide, carbon monoxide, methane, etc., said NASA scientist Drive Seth Fani Milam. The comet's emerald green glow indicates its chemical composition, the result of sunlight striking the carbon dioxide it contains. Scientists say it will be closest to Earth on February 1st. Comets are extremely difficult to predict, but if they continue to increase in brightness, they should be easy to see. NASA said in a blog post. It is also possible that it can be seen with the naked eye under a dark sky. The comet is named C2022E3, ZTF, and was closest to the Sun on January 12 and will be closest to Earth on February 1. According to the Planetary Society, it will be only 4.2 million kilometers away from Earth at that time. Snow and mud balls. Comets are large balls of ice, dust and rock, and come from a layer of icy material outside the outer rim of our solar system called the Oort cloud. Comets have a core of rock, ice, and water, and are surrounded by an outer atmosphere of ice and dust called the coma. As they approach the Sun, solar radiation causes them to eject a wave of gas and dust that gives it a smoke-like tail. That is why they are also called Damdar Sitara in Urdu even though they are not stars. The gravitational pull of many bodies in the solar system pulls them from the Oort cloud, and as they approach the Sun, their brightness increases. Every year, observatories around the world discover about a dozen comets.